is the review for the next test on ratios, rates, and scale drawing. So please have your review paper out. Please show all your work and don't forget to label. So this looks very much like the test. Same similar kind of questions. Really concentrate on this video, study this. We'll go over questions that you have when we get together next Tuesday. During a recent workout, Noah biked 7.5 miles in 20 minutes. His brother Lucas biked 8 3/4 miles, but in 35 minutes. Both Noah and Lucas thought they were the faster biker. Based on their last ride, though, who is faster? So I could do this a couple ways. This is very similar to that 211 lesson that we did, and it was Izzy and Julia. And I did it like 4 different ways with number lines and the clocks and bar modeling, and I also did it with the equation. Well, I'm going to do the equation. I'm going to find their rate. What is their miles per minute? So I'm going to do it through the rate, miles per minute, and compare those. Because they're not going the same distance and they're not going for the same time. So Noah, I'm just going to put an N here, was at 7.5 miles per 20 minutes. Well, what is he doing per minute? So if I take 7.5, which is 15 halves, and I divide it by 20, keep it, change it, flip it, is like multiplying by 1/20th. I can cross cancel 5s out of 15 and 20, and I get that Noah can go 3 times 1 is 3, 2 times 4 is 8. He can go 3/8 of a mile per minute. Lucas is 8 3/4 miles. Well, that's the same thing, 8 3/4. That would be.
Keller, please come to the main office. Madeline Keller, please come to the main office.
8 3/4 would be the same thing as 35/4 divided by 35. So 8 3/4 is 35/4 miles in 35 minutes. Well, keep it, change it, flip it, so it would be 35/4 times 1/35. Well, isn't that nice? Those cross cancel. And I get 1/4 of a mile per minute. In a minute, Lucas bikes 1/4 of a mile and Noah bikes 3/8 of a mile. Well, I know 1/4 of a mile. I could change that to 8ths. That's the same thing as 2/8. So Noah covered more distance in his minute, in his unit rate. He covered 3/8 of a mile. Lucas only covered 2/8 of a mile. Another way that I could do this, I could find a common time. I could count by 20s and I could count by 35s, and they do end up having the same time. So if I count by 20s, 7.5 miles in 20 minutes can go, and so this is Noah. Counting by 20s, 20, 40, 60, 80, 100, 120, 140 is a common minutes if I counted by 35 minutes. 35, 70, 105, 140. So I could see how far do they go in 140 minutes rather than miles per 1 minute. So I could do the unit rate, the first way that I did it, or I could find common minutes with them. So his 8 3/4 for Lucas, 35 times 4 would give me 140. So 8 3/4 times 4 would give me 35 miles. In 140 minutes, Lucas goes 35 miles. Well, 7 times 20 would give me 40 for Noah, and 7.5 times 7 would give me 52.5 miles. So you can see over a long period of time, like 140 minutes, it's almost 2 hours, that Noah covers more distance. So who is the faster rider? Noah is faster. So there's my Sable. Noah is faster. Number 2. Mrs. Garbach's car can travel 18 miles on 6/10 of a gallon of gas, and Mrs. Knack's car can travel on 21 miles on 8/10 of a gallon of gas. Who can travel farther on 1 gallon of gas? 1 gallon. It's asking me to find the unit rate. Miles per gallon. So Garbach, miles per gallon, 18 divided by 6/10, or Knack, 21 divided by 8/10. Miles per gallon. Mrs. Garbach gets 30 miles per gallon, MPG, and Mrs. Knack gets 26 and 25/100ths miles per gallon. So who goes farther? 30 miles or 26 miles? Well, obviously Mrs. Garbach's car. Mrs. Garbach's car travels or has a better MPG. Mrs. Garbach's car has the better miles per gallon, MPG. With the cost of gas, you want to have a better MPG these days. I'm going to leave number 3 to do in class on Tuesday, so we'll skip that one for now. Julia saw a sign at American Eagle that said 1/5 off the price of Cokes. Ooh, 1/5 off. If the Coke costs $85, how much is the sale price? I'm going to bar model this. 1/5 off. There's a couple ways I could do this, but I'm going to bar model it. 1/5. So I better cut my bar into 5 equal parts. And 1/5 I'm going to take off. So if the Coke was $85, so 5 of these bars, or 5 units, equals 85. So if I take 85 and divide it by 5, I'll get what one of them is. Well, that's 17. So I'm going to write the little 17s in the bars here. Now, the code says it's 1/5 off, so I'm literally going to take this $17, that 1/5, and take it off. Take it off the price. So if it started off being $85 and I'm taking 1/5 of it, which is 17, off, it ends up being $68 on sale. How much is the sale price? The sale price, full sentence answers, is $68. Number 5. The Eastside basketball team decided to put their warm-ups on sale for 1/6 off of the original price. If the sale price is $70, what was the original price? Ooh, different question. Sounds very much like number 4. Not. 1/6 off the original price. What was the original price? So the last time I knew the original price of 85. I had to find the sale price. Now I know the sale price. So yes, I'm going to bar model this. And it's going to be divided into 6ths, like this fraction shows me here. So 6 equal parts. Oh, better put another one on there. 6. 1, 2, 3, 4, 5, 6. So that's the sale price. 1/6 off the original price is the sale price of $70. So after you've taken this 1/6 off, you have 5 of these left, which equals the sale price of $70. So 5 units here. I've got to figure out how much was it beforehand. What was the original price to start with? All 6/6. So $70 is 5 of them. So if I divide by 5, I get each one is worth 14. So this is 14, this is 14, this is 14, this is 14. They are all worth 14, even the one that I already marked off. So to begin with, I had 6 of them. Well, what's 6 times 14? 84. The original price was more expensive before you took the 6th off. So I should get an answer that's higher. The original price is higher. What was the original price? The original price was $84. Number 6, describe the relationship that this graph depicts. Well, it's a straight line through the origin, so it's a proportional relationship. Proportional relationship between, and I'm going to say my y-axis first, British pounds, the value of British pounds. That's what this is talking about. British pounds and US dollars. So my y and my x, that's the relationship, and it's proportional. So you should state that. You're going to see a question just like that on the test. What does the point 6, okay, that's x, 4, x, y. So 6, 4, it's this point that they're talking about. Okay, 6 represents the x, which says 6 US dollars. So $6 US is a value of, or is worth, because it's talking about what it's worth really here, 4 British pounds. 4 British pounds. What is the unit rate? Well, it's right here. When x is 1, but I don't know. What is the unit rate? What's the k? Well, k is y divided by x. I know one point is the y is 6 and the x is 4. I also know this point, which is the y is 2. Right? The y is 2 and the x is 3. Right? The y, oh, I did this backwards. Ugh. The y in the first one, the y value is 4. Jeez, I even wrote it here. The y value is 4 and the x value is 6, because that didn't look right. 4 6 does equal 2/3. So 2 divided by 3, what is the unit rate? 2/3. Or yes, you could actually divide that out and you would get that repeating 6 on the calculator. 6 6 6 6 6 6 6 6 6 6 6 6 6 6 6, which in money, yes, you would round that up to the hundredths, because pounds are in hundredths, just like American dollars are. So a 6 with a 6 sitting next to it, that would be 67 hundredths of a British pound, y first, per 1 US dollar. That's what the unit rate is. Unit rate. Doesn't say, tell me what K is. It's asking you to find K. That's the little hint there. But you can't say K equals. Rates have to have 2 labels. 67 hundredths of a British pound equals 1 US dollar per US dollar. What point represents the unit rate? Well, the point 1, x is 1, and 67 hundredths. That's what point it is. It's hard to tell, but that's 67 hundredths here. But that's 67 hundredths of a British pound is 1 US dollar. That's the unit rate right there. It's always on the graph. Write an equation to model this data. Okay. Y equals, the equation's always, the general formula is y equals kx. Well, I know what k is. Y equals 67 hundredths x. What does the point 0, 0 represent in this situation? Meaning with this story, not the origin. 0 US dollars, say the x first, the x-axis is US dollars, is worth 0 British pounds. 0 British pounds. So you got to put the story when it says in this situation. What are the variables? Say x first and then y. What does, it's not the origin. In this story, it's 0 US dollars is worth 0 British pounds. Number 7. I'm going to leave number 7 for us to do in class on Tuesday. So I'm going to go on to number 8. A picture of a rectangular classroom measures 5/8 of an inch by 7/8 of an inch. A scale in the corner says 1/8 is really 4.5 feet. Represents 4.5 feet. What are the actual dimensions of the classroom? Okay, so I'm going to take this one first. Maybe this is the length and this is the width, let's just say. So if 1/8 is really 4.5 feet, right? 1/8 is 4.5 feet. I'm going to use that scale. So 1/8 is 4.5 feet. What would 5/8 be? Right? Y over x has to equal y over x. My original is the x, and my scale is the y. So this is my y over x. My scale drawing over the actual. So the scale drawing over the actual, or the real thing. Scale drawing over the actual. So 4.5 feet. So, I can see that this is multiplied by 5. So if I take 4.5 and multiply it by 5, I'll have equal ratios. So that would make that 22.5 feet. So I did part of it. I did this, the length. Now let's do the width. Same scale, 1/8 of an inch on the scale picture is really 4.5 feet on the actual thing. So the scale drawing over the actual, the original or the actual picture. Now it went up to 7/8. Well, what's that going to give me here? What am I going to have here? Well, I can see that's times 7. So this times 7, 4.5 times 7 would give me proportional relationship. Equal ratios is a proportion. 4.5 times 7 is 31.5 feet. So what are the actual dimensions of the classroom? 22.5 feet and 31.5 feet. The length and the width. What is the area of the classroom? Oh, it's a rectangle. Area equals length times width. Hopefully you remember that. Length is 22.5. And it doesn't matter if I call the length 31.5. I could switch these because I could commute that, right? Commutative property says 22.5 times 31.5 is the same thing as 31.5 times 22.5. And I would get 708 and 75/100 feet squared. How many of you remembered that? Square feet in area. A tile must cover the entire classroom floor. Yes, we don't want to have open spots on our floor. If one package of tile covers 9 square feet, how many packages will you need to cover all of this? 708 and 75/100 square feet. Well, one covers 9. Divide this by 9, right? Would make sense. And you would need 78 and 75/100 of a package. Can you buy part of a package? No. So I would have to round this up to 79 packages would be needed. Yes, you'd have a tile or 2 left over, which is good in case you get a chip in one or something, you can replace it. And that's it for today. We'll finish the rest in class.